there, folks. Root Beer here with question number 6 on the 2017 Euclid contest. This is a two-parter question, one light bulb, one written question, or one written portion. So our light bulb question, where we just need the final answer, the diagram shows two hills that meet at O. One hill makes a 30-degree angle with the horizontal, and the other hill makes a 45-degree angle with the horizontal. Points A and B are on the hills so that OA is equal to OB. So maybe O is the center of a circle, and these are our radii. And we know that that's 20 meters is that length. Vertical poles BD and AC are connected by a straight cable CD. If AC is 6, what is the length of BD for which CD is as short as possible? Okay, so we just want to sort of minimize CD. Let's copy the picture. I want a bit more space towards the top. We get 45, we get 30, we go up. This is 6, this is 20, and then we go up a bit. We have A, C, B, D is also 20, so these guys are degrees. We'll denote that. So we've got CD here. Now, if I want to minimize CD, and that is what I want to minimize, right? Vertical poles, BD, and AC are connected. Okay. So I want to minimize CD. Well, I think it will minimize when CD makes a right angle at D. The reason being, imagine this right angled triangle. If I just shorten BD so that CD lies flat along this line here, it'll be shorter because the hypotenuse is longer. And you might say, okay, but what if we shorten it even more? Well, we can draw another picture here where CD happens to be even shorter, but that's still 6, and then we get B and D. But now by lengthening it, CD is this hypotenuse, by lengthening it up to where it's parallel to this hypotenuse fellow here, and my bamboo paper thing is getting in the way. But by extending BD, we can make CD fall up here. So yeah, I would say we need CDB to be 90 degrees. Okay, so we need it to be 90 degrees. So that's our setup. So we'll draw this picture once more, but now we know exactly what we want. 6 degrees here. We want a 90 degree here. So 45 degrees, 30 degrees. Okay. So we got 20, we've got 20. What are we to do? We don't care about the length CD, but we do want the length DB. Well, I'll tell you what we can do. Drop these perpendiculars down here. We know the hypotenuse is 20, so I can figure out not only this distance here, but also the height A and B are off the ground. I mean, that's going to be, so opposite the angle, so it's going to be 20 sine 45 degrees, and we're using SOHCAHTOA here. So the sine is the opposite length over the hypotenuse. Rearranging, we get the opposite length is the sine times the hypotenuse. So sine of 45 times 20. Likewise, over here, we will have 20 times sine of 30 degrees is how far up we are there. But notice we got all these right angles here. This one will also have to be a right angle. So I might call this X and Y. Notice that XCDY will be a rectangle. So that tells me that Cx is going to be equal to dy. Now Cx is 20 sine 30 plus 6, and dy is 20 sine 45 plus BD, the length we want to solve for. So BD is just going to be 20 sine 30, so that's 20 times a half, plus 6, minus 20 times sine 45, so that's a 1 over root 2. That's going to be a half of 20 is 10, 10 plus 6 is 16, minus, so take a 10, put a 2 here, 2 over root 2 is 2, so minus 10 root 2. And that is the length that BD must be. Okay. So there we go, not so bad. Key points there, we had to realize we needed a right angle. That was kind of crucial. So I'd say those two pictures and this conclusion would be enough to earn a part mark if that is part of the marking scheme. And then, yeah, definitely putting this this x and y here, realizing it's a rectangle, gets us this equation. Quick rearrange and solve. Yeah, there's your 3 marks, maybe 3, 4, maybe. All right, so that's A part done with. Now now B part. If cos theta equals tan theta, determine all possible values of sine theta, giving your answers as simplified exact numbers. So no rounding, nothing like that. Okay. So I look at this equation, I say, there's no sine theta in there. How am I supposed to even start talking about sine theta? Okay, do I need to solve for all possible values of theta, start plugging them into sines? Not at all. Remember the definition of tangent, it's sine over cos. So we can start with this equation and very quickly introduce a sine. So now we have a sine theta here. Okay. And I don't like this cos theta on the bottom, so I'm going to rearrange and get cos squared is equal to sine theta. Okay. Notice it's a written part. I'm showing my steps, but I'm not actually saying anything. I mean, if you want to, you can write rearrange or multiply by cos theta here. But I would say as long as your equations are nice and clearly laid out, this is all fine. I mean, you can follow what we've got here. We have our starting equation. We rewrite tan, multiply by cos. Now we just want to talk about sine theta, so I'm going to rewrite this now as 1 minus sine squared theta. And now I've got a quadratic in sine, so I'm going to bring everything over to the other side. It'll be minus 1, yeah. And now I'm going to say let x equal sine theta. So 0 is equal to x squared plus x minus 1. I don't think I'm going to be able to factor just because we've got a whole bunch of 1s here. So I would say something like by quadratic formula, we have x, and therefore sine theta. So we'll say sine theta is negative b, oh I don't like that negative 1 there, plus or minus the square root of b squared, 1 squared, minus 4ac, but there's already another minus sign in there, so plus 4 all over 2. Okay, now the fact that we divided by 2 is a little better. I was worried with this minus 1 there, because remember sine is between negative 1 and 1. So we can get negative 1 plus or minus root 5 all over 2. So that should be our answer for sine, but we've got 2 different values here. I would, and this would be true for any trig question, I would recommend you get out your calculator and actually evaluate these to make sure that your sine is actually in the proper range. So I would say something like negative 1 plus square root 5 all over 2. Okay, 0.618, that's fine. That's a fine sine value, and they probably are both fine. But you got to double check these things. Sine and cos have to be between negative 1 and 1. Things like solving for values of tan theta, anything goes. So don't worry about tan theta, but sine can sometimes be a problem. So negative 1 minus root 5, that's the other possibility. Divided by 2 is, negative 1.618. And that's 2 negative. So we'd say, but negative 1 less than or equal to sine theta less than or equal to 1. So sine theta can't be negative 1 minus root 5 all over 2, because that is approximately negative 1.618, yada, yada, yada. 0.33989. It's the negative version of the golden ratio for people who like that sort of stuff. So the only possible value for sine theta here is negative 1 plus root 5 over 2. And we're going to keep it as an exact answer. We could write that this is 0.618 and so forth, but we don't need to, because they did say exact answers. So notice there that even though they gave us an equation with no sine thetas in it, we didn't have to actually solve and say, theta must be pi by 5, or pi by 5 plus 2 pi, or whatever it is. We didn't have to, we have no idea what theta is. Doesn't matter, we could still get sine theta. And notice also this occasional trick, you didn't really need to do it a whole lot in this one, but expressions that are quadratic in something other than x or y, we can introduce a variable here. We just have to be careful because sine and cos are bounded. So we had to do that little double check there. But that wraps up question number 6, and a nice little question it was. I will see you guys for question number 7 in the next video. Thanks for watching.